Hello, welcome back to the VDC space. Today we're going to be doing something more interesting. We're going to be doing an expansion joint for bridges. So based on its design and specification, it's mainly used for heavy traffics. So it's going to be an interesting tutorial today. So we're going to create we're going to have six different families. Five of them we're going to create on our own, and one of them we're going to load them from the Autodesk library. So we're going to have the angled fasteners, we're going to have the studs, the anchor loops, the anchor plates, the strip seal, and the clamping systems. So we're going to create intelligent families um, on different on we're going to create different families on the same template, and then we're going to join them together. We're going to combine them together as a single family and then load them into our project, and then create intelligent parameters in order for us to control the family on our project. Now, before I get started, I would like to ask you guys to please subscribe to the channel if you're new. If you already subscribed, hit the notification button as I upload BIM modeling tutorials and Revit tutorials 3 times every week. I cover different topics from wastewater to structural, architectural, roads and earthworks, bridges, civil structures, and so on. So without further ado, let's jump into Revit. So here we are in Revit 23. So the first thing is we're going to open up a new project using the construction template. And then for our first family, we're going to create the start. So we're going to go with file, new, and then family. And then we're going to drop down. And then for all our families, we're going to use this template, metric specialty equipment. And then we're going to open it. And now we're going to go to the front elevation. And then we're going to say reference plane and then place a horizontal reference plane randomly like this. And then we're going to select it and adjust the offset. So we're going to make it 60 millimeters for the entire thread of our start. And then we're going to go back to the reference level and go to create extrusion. And then we're going to select our circle option. And then from this insertion point, we're going to have a circle of radius 3 millimeters, enter. So the diameter is going to be 6 millimeters. And then we're going to say finish edit mode and then go back to the front elevation. And then we're going to drag our extrusion to the bottom and then lock it. And then grab it from the top and then drag it towards this reference plane and then lock it. So the one thing I forgot to tell you is for our studs or our bolts, we're not going to go into too much detail. We're just going to keep it from level of detail 100 to 200. We're not going to model uh, um, those steel higher level of detail steel threads as you see them on the bolts. We're just going to keep it as simple as you can. So we're going to go back to reference level. And then actually, while we're still at the front elevation, you're going to go to create and say swept blend. And then you're going to say sketch path. And then from this insertion point, you're going to take it upwards by 3 millimeters and press enter. And then you're going to say finish. And then you're going to select profile 1, edit profile, and then go to the floor plan reference level, open view. And then you're going to select your circle again, and then from this insertion point you're going to apply the same radius of 3, so your diameter is going to be 6 millimeters, and say finish. And then you're going to say select profile 2 and say edit profile, and then you're going to select your circle again, and then from this point you're going to extend it beyond 6 millimeters. So you're going to make the radius 6 millimeters, which means your diameter is going to be 12 millimeters, and say finish, and say finish edit mode, and then open up the 3D view. This is what we have. Now the second last thing is you're going to go back to the reference level and then just set this to fine, and then set your graphics to hidden lines. And now you're going to create a void extrusion on in the middle of your stats. So you're gonna go to void forms and then void extrusion, and then randomly place a rectangle like this, and then you can manually adjust the offset. So from this point, you're gonna offset it by 2 millimeters from this side. So the horizontal lines are gonna be 4 millimeters apart. It's gonna be the same case this side. So one side, you're going to adjust it by 2 millimeters, and then select the other side, and then make the total 4 millimeters. Perfect. And then the next thing is you're going to select your line, and then place two horizontal lines like this on each side, and then you're going to select your lines, and then you're going to offset them by 1 millimeters each side. You're going to select offset them by 1 millimeters, and then select your straight lines again, and then you're going to draw a diagonal line from this insertion point to this point, and then you're going to do the same thing this side, and then you're going to do the same thing on the other side. The next thing is you're gonna select these two lines, and then remove them, and then select these two lines and then remove them, and then you're gonna go to trim and extend, and then trim and extend, trim and extend, and then trim and extend. Then you're gonna say finish edit mode, go to the front elevation, and then just manually adjust your void extrusion, and then from the top you're gonna drag it until this point, and then you're going to hover over your extrusion and then press tab on your keyboard until you are left with an option of selecting this line only, and then you're going to adjust the depth, so you're going to make it 2.5 millimeters. Perfect. And now you're going to go to the 3D view, so this is what you have. Now the last thing is you're going to apply material to this, so you're going to select your solids and then go to material, and then you're going to type in steel. And then you're gonna make it steel S355, load it in, apply, and then OK. And then you're gonna save this. So let me just remove these. So you're gonna create a folder called expansion joint family. So you're gonna remove, so let me just remove this. You're gonna create a folder called expansion joint family, and then that's where you'll save your family. So I'm gonna name this one studs and say save. And then I'm gonna close down the family template. So we modeled our studs, check. Now we're gonna go to file again, new, and then family, and then we're gonna go with this metric specialty equipment again and say open. And now the next thing is we're gonna model our anchor loops. So for our anchor loops, we're gonna go with the front elevation, and then we're gonna go with the sweep, and then we're going to say sketch path, and then from this insertion point we're going to take it down by 250 millimeters, and then to the right by 300 millimeters, and then we're going to take it diagonally by an angle of 145 degrees, and then we're going to say fillet arc, and then say radius, and then type in a radius of 30 millimeters, and then you're going to select these two lines to apply our fillet, and also this side we applied our fillet. Now we're going to say finish, and then we're going to say edit profile, and then for our work plane we're going to set it to floor plan reference level open view, and now we're going to select the circle option, and then from this insertion point we're going to apply a radius of 7.5. So our anchor loops will have 15 millimeters in diameter. So we're gonna say finish edit mode, open up the 3D view. So this is what we have. And now we're gonna select our anchor loops, apply the material to this. So we're gonna say steel, and then we're gonna load in steel S355, load it in, apply, okay. And now we're gonna save this onto our folder, and then we're gonna name this anchor loop. And then we're gonna say save, and then we're going to close this down. So perfect. And now we're going to create our third family. We're going to say new family, and then we're going to scroll down and say metric specialty equipment and say open. And now we're going to model our anchor plates, which is the most simple one we can do. So on both sides we're going to place horizontal reference planes, and then we're going to offset them from each side by 10 millimeters. And then we're going to go to the front elevation, and then we're going to say create and then extrusion, and then from this insertion point we're going to take it upwards by 80 millimeters, and press escape. And then from this insertion point, we're going to take it to the right by 125 millimeters, and then we're going to take it upwards by 30 millimeters, and then escape. And then from this point again, we're going to make it 30 millimeters, and then from this point we're going to draw a diagonal line until this insertion point. So this is what we have. So we're going to say finish edit mode, go back to the reference level, and then we're going to drag it to this reference plane, lock it, and then select it and drag it to this reference plane and then lock it. And now we're going to open up the 3D view and then select our anchor plate, apply the material to this. So we're going to say steel again, and then we're gonna load in steel S355, load it in, apply, okay. And then we're gonna save this as our anchor plate. And we're gonna say save and then close down our family template. And now our fourth family, we're gonna go with new again, family, and say matrix specialty equipment, open. And now we're gonna model our clamping system. Now this is gonna be much more interesting. So we're gonna, while we still are on the floor plane or reference plane, we're gonna place two vertical reference planes on each side, and then we're gonna select them and then offset them from the center reference plane by 1,500 millimeters. And then before we model our geometry, we're gonna select our dimension and then apply the length dimension by using these reference planes. And now before we construct our extrusion or geometry, we're gonna have to we're gonna have to add a parameter to this just to make it more intelligent. So we're gonna say create parameter, and then instead of it being a type, we're going to make it an instance parameter. The reason why we do this is because I want us to generate a drag control or drag point. So I'll show you guys what I'm talking about. So we're going to set it to instance parameter, and then we're going to name it the length and say okay. Perfect. And now for our geometry, we're going to go with the left elevation, and then we're going to say create and say extrusion, and then we're going to select our rectangle option, and then from this insertion point just randomly draw a rectangle, and then we're going to offset it from this side by 30 millimeters, and then from the top we're going to also make it 30 millimeters. And now we're going to select our line, and then we're going to offset it from this block by 15 millimeters, actually by 5, and then we're going to take it upwards by 30, press escape, and then from this point we're going to take it to the right by 45 millimeters, and then take it upwards by 15 millimeters, to the right by a further 15 millimeters, and then take it down by 7.5, take it to the right by 10, and then take it upwards by 15, press escape, and then from this point you're going to take it to the right by 60 millimeters, and then diagonally until you meet this insertion point. Perfect. Now you're going to say finish edit mode, go to the reference level, and then you're going to drag it towards this reference plane and then lock it, and then drag it to this reference plane and then lock it. And now you're going to open up your 3D view and then select your extrusion and then apply the material to this. So you're going to say metal, you're going to say steel, and then you're going to load in steel S355 and then apply okay. Now let's go back to our parameter. Remember, I advised you guys to set this length to an instance parameter. I'll show you why um, I said so. So remember, we opened up our project using the construction template. So we're gonna load in our project into our family into our project. So I'm gonna set it like this. The reason why I advised you guys to set it to instance parameter is to create these these two arrows at the ends of your family, which I call it the drag controls or drag points. So you can manually select your geometry and adjust the length of your family instead of you typing it on your properties panel. So yeah, it makes it much more easy in terms of controlling the length of your family. So yeah, that's the reason. So I'm just gonna remove this and then go back to my family. So I'm gonna save this, and then name it clamping system and say save. And then I'm gonna close down my family template. And then the last thing I'm gonna create is I'm gonna say new and then family. And then I'm gonna go to metric specialty equipment and say open. And then the last thing I'm gonna create is the strip cell. So we're gonna apply the same logic we did with the clamping system. So I'm gonna say reference plane, and then I'm gonna place two reference planes on each side. And then I'm gonna select this reference plane, and then I'll set it by 1500 millimeters from the middle reference plane. And then I'm gonna choose my dimensions and then apply my length, select it, and then create parameter, set it to instance, and then I'm gonna name it length and say okay. And then I'm gonna go before I go to my left elevation to set my profile. I'm gonna use the clamping system as my reference in order for me to construct my strip seal, because my strip seal is gonna be placed between two clamping system. So having my clamping systems will be a great guide on how I can construct my strip seal. So I'm gonna go to insert, load family, and then I'm gonna go where I saved my families. So I'm gonna go under expansion join family. So I'm gonna load in my clamping system open, and then go to create component, and then I'm gonna place my clamping system this side, and then I'm gonna go to the left elevation and then apply my dimensions from this reference plane to this point, select my clamping system, and then I'm gonna offset it by 100 from the middle reference plane. Remove my dimension, select my clamping system, go to mirror pick axis, and then copy it to the other side. And now I can construct my profile for my strip seal. So I'm gonna go to create and then extrusion. And then from this point, I'm gonna construct my profile from my strip seal. So from this point, I'm gonna take it diagonally by 60 degrees. Actually, I'm gonna remove this. I'm gonna set it right there. And then from this point, I'm gonna make it 60 degrees. And then from this point, I'm gonna bring it down like this. And then I'm gonna select all these lines, go into mirror pick axis, and then pick my middle reference plane, and then it's copied to the other side. Now, as you can see, it doesn't look right. I don't want these pointy edges, so I'm gonna apply the fillet because this thing is made up of rubber. So I'm gonna say fillet tag, and then apply a radius of 3 millimeters, and then from this point I'm gonna make it 3, and then this I'm gonna make it 3, and then let's go this side. So I'm gonna apply 3 this side also, and then I'm gonna apply a radius of 5 millimeters. So I'm gonna apply 5 there, 5 here, and then 5 there, and then 5 there. And now for this side, I'm gonna apply a radius of 15 millimeters, and let's see what happens. And also this side, I'm gonna apply 15. So I'm gonna reduce this one and make it 10 instead, just for it to look right. So perfect, this is what we have. Now, I want us to add a parameter to control the angle of how the rubber can extend during traffic or during the bridge movement. So in order for us to do that, we're going to go with the dimension and say angled, and then select these two lines first, the outer lines, and then apply our angle. And then we're going to select these ones right in the middle, and then take it upwards. And then we're going to apply our parameter to this. So we're going to select this one and say create parameter, and then we're going to name this movement capacity and say okay, and then we're going to lock it, and then we're going to select this dimension, and then under label we're going to drop down and apply the same parameter. So I'm just going to reduce the scale just to see things more clearly. And then under properties, you're going to go to family types, and then just to test our our parameter. So I'm gonna change the movement capacity from 60 to 45 degrees and say apply. And as you can see, this is what it does. And then I'm gonna change it to from 45 to 75 and say apply. So as you can see, this is what it does. So it changes the movement and without it moving away from the clamping system. So this part still stays under the clamping system, but only this part generates movement. So it's much more intelligent. So I'm just going to change it back to 60 degrees and say apply and then OK, and then finish edit mode, and then go back to the reference level of floor plan and then drag it towards the reference planes and say lock it. And then I'm going to drag it towards this side and say lock it. And now the next thing is I'm just going to remove these clamping systems. We have no use for them. And then go to the 3D view, select my extrusion, and then apply the material to this. So I'm just going to type in rubber. And then I'm going to drop down. So I'm just going to use this rubber natural and then load it in, apply, and say OK. And now I'm going to save this under our folder. So I'm going to name this one strip seal and say save. Now I'm just going to close down my family template, and basically we are done generating our all our families. Remember the last family, we're gonna load it in from the Autodesk library, which is sort of like a beam which we are going to use as a fastener. So yeah, uh, considering that we've generated our families, now it's time to assemble everything. So you're gonna go back to file, new, and then go to family, and then we're going to use the metric specialty equipment, and then you're going to say open. And now this is going to be the trickiest part that we can do. I'm going to apply this in terms of two different options. I'm going to assemble everything, and then load the family into our project, and then just keep the family's aesthetic. I'm not going to make it intelligent in such a way that when we extend the length of our expansion joint, the goal here is I want to make this family intelligent to the point whereby when you extend the length of your expansion joint, I want the bolts and also the anchor loops and the anchor plates to extend along with the length. So yeah, that's the goal. So I'm just gonna select this reference plane, unlock it, and then extend it beyond and lock it again. I'm gonna select this one, unlock it, and just extend it beyond and then lock it again. And now I'm going to say create, go to reference plane, and then add another reference plane this side, which is the same size as this one, just to show it this is the end of our family. And then I'm going to select it and then set it to a reference of offset it by 6,000 millimeters. The next thing is I'm going to add another reference planes which are smaller, and then I'm going to add it this side. So I'm going to add 3 this side, and then I'm going to add 2 this side. And now I'm going to select this one, and then I'm going to offset it by 250 millimeter from this reference plane. And then this one also I'm going to offset it by 250 millimeters from this reference planes. So I'm going to apply the same logic this side. So it's going to be 250. This one also 250. This one also 250. Perfect. Now let me just extend this so they become, yeah, perfect. And now the next thing is I'm going to apply intelligent parameters to this. So I'm going to go to my dimensions and apply my dimensions this side, and then apply my other dimensions from this point to this point. And then I'm going to apply individual parameters for this point, and then between these two, and also these two. And then I'm going to apply another one this on these two. And then from this point, I'm going to apply other dimensions until this point. So here we go. So basically we are done applying our dimensions. Now we can add parameters to this. So I'm going to start with this one and say create parameter. And then I'm going to name this one draft. draft length and say okay. And then I'm gonna go down and then select this one and say create parameter. So this one, we're gonna make it an instance parameter, and then I'm gonna name it actual length and say okay. And then I'm gonna go with this one and say create parameter, and then I'm gonna name this one array length, and then I'm gonna make it an instance parameter also and say okay. And then I'm gonna select this one and say create parameter, and then I'm gonna name this one offset, and then I'm gonna make it an instance parameter also and say okay. And then go to this side and then select this under labels. I'm gonna drop down and then assign the offset parameter to this, say remove constraint. So the array length, let me select my array length and say set it to, so I'm just gonna remove this, select this and say set it to array length. And now I'm gonna select this one and say create parameter, and then I'm gonna name this one array distance and say okay. And then this one also, I'm gonna set it under labels. I'm gonna drop down and then set it to array distance. And let me just apply dimensions to this. So I'm gonna select this one and then set it to, so it says the reference planes are over constrained, so I'm just gonna remove this. And now the next thing is we're gonna have to apply our, let me just reduce the scale just to see things more clearly. So the next thing is we're gonna have to place our geometry. So the first thing is I'm gonna go to insert and then load family, and then we're gonna load in our family. So I'm gonna start with the strip seal and say open, and then load family again, and then clamping system, load family again and say the studs, load family, and then our anchor loops and our anchor plate. So just load everything you have created and then go to create component. So the first thing we're gonna place is our strip seal. So I'm just gonna place it right in the middle like this. So just make sure it is centered, and then I'm gonna lock it this side, and then I'm gonna select it and then drag it towards this, the second last reference plane, and then I'm gonna lock it. And then now I'm gonna go to the left elevation, and then yeah, I think it's all right if it's on this reference. So I'm gonna go back to my reference level, and then the next thing is I'm gonna go to component and then drop down, and then I'm gonna place my clamping systems. So for my clamping systems, I'm gonna randomly place them, and then so I'm gonna lock it. I'm gonna press AL on my keyboard or align, and then select my reference plane and then my clamping system and then lock it. And then this side, I'm gonna drag it towards the second last reference plane and then lock it. And then go to my left elevation just to adjust it. So I'm gonna move it like this. So this is what we have. And now I'm going to select my clamping system, go to mirror pick axis, and then pick this middle reference plane, and then it's copied to the other side. And then I'm going to make sure that it's locked with the reference plane. So I'm going to say align and then clamping system, lock it, align, clamping system, and then lock it this side. And now the next thing is we're going to place our bolts, our stats. So go to component and then drop down. So you're gonna say stats, and then right in the middle like this, you're gonna place it like this, and also this side you're gonna place it like this by using this reference plane. And then you're gonna go to the left elevation, select your studs, and then you're gonna adjust the height, and then from this point you're gonna take it upwards until it's on top of until this point is on top of your clamping systems. Perfect. And now go back to the reference level and then select your studs. Actually, we're gonna place, just go to create and then component. We're gonna place your your anchor plate. So to change its orientation, you can press spacebar on your keyboard and then randomly place it like this. Go to your left elevation, and then you're gonna say move, and then from this point you're gonna move it like manually. You're gonna move it like this, and this is how you can place it. So you're gonna say, while it's still selected, mirror pick axis, and then pick this middle reference plane, and then it's copied to the other side. Go to your reference level, and then you're gonna say component again, and then place your anchor loops. And then for your anchor loops, you're gonna place it like this, and then select it. Go to the left elevation, and then you're gonna, from this point, you're gonna drag it until this point, so you can just nudge it so that it doesn't clash with the studs. And then while it's still selected, go to mirror pick axis, and then pick this middle reference plane, and now it's copied to the other side. Just open up the 3D view, and this is what we have so far. So you can just change this to shaded, is to fine. So this is what we have so far. And now the next thing is you're gonna go to reference level, and then this is the tricky part, is setting up your arrays and all that. So you're gonna select your bolts, your anchor loops, and your anchor plate. So you're gonna say Control Select, and then you're gonna copy them to the other reference plane like this. While they are still selected, you're gonna say array, or you can type in AR on your keyboard, and then you're gonna set your number to 22, and then make sure your constraints are set to last. And then from this point, you're gonna select and then drag it towards this reference plane. So everything is gonna be copied, and then you're going to select the dimension line for your array, and then you're going to add a parameter to this. So you're going to set this parameter to an instance parameter, and then you're going to name it array. You're going to name it array, and then make sure it's group under other. So you're going to say okay. Perfect. And now the next thing is, so when you go to your 3D view, this is what we have so far. So the next thing is we're gonna place our angled steel fasteners. So that's the only thing missing. So when you go to your reference level, we're gonna say insert, and then load family, and then under metric library, you're gonna go to UK contents, and then structural framing, and say steel, and then British standards, and then say L equal leg angles open, and then you're going to choose the option of 100 by 100 by 10 and say open. Go to create component, and this is your beam. So you're going to randomly place it like this, and then set your level of detail to fine just to see it, and then set this to hidden line, and then go to the left elevation, and then set your level of detail to fine, and then you're going to select your beam, and then in order for you to move it more freely, you're gonna just add random numbers to your start level offset and your end level offset, uh, in order for you just to move it. So I'm just gonna change its orientation, so you can go to the cross section rotation, and then I'm gonna set this to -90, and then I'm gonna select this point, and then I'm gonna place it right at this point. And now I'm going to go back to the reference level, and then just set this to wireframe to see everything. So I'm going to, so this is okay, yeah, this is my beam. So I'm going to select it and say mirror pick axis, and then pick this middle reference plane, and then it's copied to the other side. So I'm going to say aligned, and then aligned everything that's interacting with this reference plane and also this reference plane. So I'm going to select my reference plane, and then I'm going to start with my clamping system and then lock it, reference plane, clamping system, and then lock it, reference plane, and then my beam, my fastener, reference plane, and then my fastener, reference plane. So yeah, this is the logic. In order for you to control its length, it makes it much easier. So you're going to do the same thing this side, reference plane. Perfect. And now the last thing I forgot to do is you're gonna lock your components along with this reference plane at the start of your array and also at the end of your array. So I'm gonna select my reference plane and then my anchor loops and then lock it, reference plane, and then my anchor plates, lock it, and then reference plane, and then my bolt and then lock it, reference plane, anchor loops, lock it, reference plane, and then bolt, and then lock it, reference plane, and then my anchor plates, lock it. Right at the beginning of your array, so it's this part, reference plane, anchor loop, lock it, reference plane, your bolt or your studs, lock it, reference plane, your anchor plate, lock it. Reference plane, anchor loops, lock it, reference plane, anchor plate, lock it, reference plane, your studs, lock it. Perfect. And now the next thing is I'm gonna have to add a parameter which controls the length of your expansion joint so that these the anchor plates and the anchor loops and your studs may multiply when you control the length of your expansion joint. So it's much more complicated, guys. So, but uh, when you go to the 3D view, this is great for visualization. So you can still load it into your project and just use it for visualization. So yeah, I think that's great. But you can also take it further by adding much more parameters to this. So I'm gonna go with under properties, I'm gonna go to family types, and then under my offset, under formula, I'm gonna type in 250 millimeters. So here we go. And then on my array, on my formula, I'm gonna add a formula to this. So I'm gonna say open bracket and say two open brackets and say draft the length and say minus 250. And then I'm gonna close down my bracket and say divided by array distance and say minus 1, and then I'm gonna close down my, I'm gonna say close bracket. So I'm gonna say apply and then okay. And now I'm just gonna load this family into my project and see how it behaves. So I'm just gonna place it like this. So this is what we have. Now when I extend it, let's see what happens. So as you can see, when I extend my expansion joints, my loops and my studs and my loops, my studs, and also my plates do not extend along with it. So that was what I was trying to achieve by adding formulas to this family. So I'm just gonna say undo, select my family, edit family, and then I'm gonna go, let's try this method. I'm gonna go under properties, I'm gonna go to family types again, and then under my array length, I'm gonna say open bracket and say array plus 1 close bracket multiply that by array distance and say apply, then okay. Let's see what happens. Load it into project, override the existing and its parameters. So let's see what happens. So if I extend it, so it's still the same situation. So I'm just gonna say undo and then select my expansion joint and say edit family, and then I'm gonna say undo also this side, and then I have to assign a family towards this dimension. So I'm gonna drop down and then set it to offset. I'm gonna say actually I'm gonna remove this one first, then set this one to offset, and then I'm gonna select my dimensions again from this point until this point, and then I'm going to select this, drop down, and then set this to array length. So if I go under properties, family types, and say, let's see, array length, and then go to edit. So it's set to an instance parameter. So if I change it to type, let's see what happens. Say OK. Then I'm going to drop down and say array length. So it still says it's over constrained. So I'm just going to say cancel, then remove this, and then drop down, make this array length. And now let's load it to our project. So if I open my 3D view, and this is what we have. So yeah, I think, guys, this is much more helpful in terms of visualization. So if you are maybe working for a company that produces expansion joints, I think this is great for them, just to quantify everything and see how everything looks in a 3D space. Or maybe you guys can show this, you can take this to Navisworks and then construct an assembly model showing how this thing is assembled by using this 3D geometry. So it's still much more helpful and intelligent. Yeah. So yeah, I didn't want this video to become long in terms of working with parameters, because I know there was a lot of struggle when I actually made it to work how I want it to work. So yeah, I just want to keep this video as short as I can. Let's just select this and then go back to edit family. I want to figure out why this doesn't work like it did before, because when I go to properties and then family types, and then set the array length to an instance parameter, and say OK, and then the offset, I think the offset is fine, and then the array formula, it's still fine, and so everything looks fine actually. So I'm gonna say OK, and then go to my dimensions and apply the offset dimensions there. Then I'm going to select this. Let's make sure that the offset is an instance. Okay, the offset is an instance parameter also. So I'm going to select this, drop down, set it to offset. I'm going to say show. So I'm going to say cancel. So it's over constrained. Remove constraint. Let me select my array and see, okay, this is what we have. And then array distance. Our array distance, it's not an instance. Okay, that's fine. And then our offset is an instance parameter. Our actual length is also an instance parameter. And then our draft length, our array length is also an instance parameter. And then our draft length, it's not an instance parameter. So I think everything is perfect, and I don't know why it's acting like this. So families are sensitive and act different. So I'm gonna say override and see what we have. When I go to level 0 and then select this and then drag it. So as you can see, it still extends, but the anchor loops and the studs and the anchor plates do not extend. But yeah, so I think this is just great for visualization. So yeah, the parameters are much more complicated than one can even imagine. So if I go back to edit family and then say properties, family edit type, and then set the array length to open bracket and say array plus 1 close bracket multiply by array distance, and say apply, and then OK. Okay, so this is what we have. So if I select this and then drop down and then set it to offset, let's see what happens. So it doesn't want to. I'm gonna say remove constraint and say load into project, override. So let's see. So if I extend this, still doesn't work. If I extended this side, so the only thing that extends is my strip seal and my clamping system. So, but this is okay for now, as just use it for visualization. And yeah, I hope you guys learn something from this tutorial, and I hope I can catch you on the next tutorial. I'm gonna be modeling a concrete girder bridge. So yeah, please tune in, like, subscribe, and comment. So yeah, this wasn't an easy task to do, as you can see from my previous post. I said this was a very intelligent family and complicated. So yeah, thank you guys, and I'll catch you on the next tutorial. Peace.